the first thing I want to start in on today is the idea of graphs of equations. And we already have this notion of points in the Cartesian coordinate system. Point x, y corresponds to an address by letting that x and y tell you how far to go to the left and right and then up and down. That means that anytime you have something that involves two numbers, you can think about the graph of that thing that involves two numbers. But this equation, 2x minus y equals 6, what does that mean? That just means, it's a way of referring to, all points x comma y with 2x minus y equals 6. So if someone asks you whether or not a point is on a graph, they're just asking you if those two numbers satisfy the equation. Or inequality, we talk about graphs of inequalities too. So, as just a quick demo, here are two different yes-no questions. Are these points or are they not on the graph of this same equation, 2x minus y equals 6? So how do you test that? You just need to test if you plug in this value for x, that value for y, do you satisfy this equation? So if you want to test whether this point is on the graph, that means you need to determine is 2 times x minus y, is that equal to, I'll put a question mark there because I don't know whether or not it is that equal to 6? And just by looking at that, is that equal to 6? No. I guess it's negative 2, I think. But it doesn't matter that it's negative 2. So, what can you conclude? You can conclude that 2 comma 6 is not on this graph. How do people feel about that? If you want to tell if something's on the graph, just plug in those numbers and see what you get. So tell me, is 5, 4 on the graph? I see some thumbs up. I see some heads nodding. Do I hear any no's? I'll pause for a moment as long as it looks like people are still computing. Do we have universal agreement? Should I go through and do it? Nice. So this point is on the graph. And what we'll do on this next table is we'll try to figure out what this graph looks like by finding many points on the graph. And maybe I'll even begin by adding 5 comma, that's about where 4 is. 5, 4 is a point on this graph. And let's find some other points. So here's one strategy for getting an idea of what a graph looks like. Let's fix a bunch of different values for x. Let's figure out what y value, if one even exists, results in that point being on the graph. We'll sketch those dots, and then we'll try to interpolate between. We'll see what the graph winds up looking like. So I think the way I'm going to proceed is I'm going to plug in x equals 2. I'll let you all plug in some more points and tell me what the y values are. We'll figure out what y corresponds to x equals 0 by solving that equation when x equals 0. We'll see what we get. So plug in x equals 0. It looks like we get 2 times 0 minus y equals 6. That look easy to solve for y? Yeah, I guess like I said, I would do it, so maybe I should go through the walk of solving. 2 times 0 is 0, so it's just minus y equals 6. Multiply both sides by negative 1 to get rid of the negative sign. I think I see y equals negative 6. So that means that the point x equals 0
this x value, x equals 0, comma, this y value of negative 6 is on the graph. I'll draw that point then. X equals 0, y equals negative 6. 1, 2, 3, 4, 5, 6. So far we have 2 points on this graph. That's definitely not enough to have a really solid idea of what this graph will look like, so let's find a couple more. So I think the right thing to do is, there are many people in this room, and there are like 3 computations listed to do. I think I'll wait you up to do them. X equals 2. Middle-ish, x equals 4. This side-ish, x equals negative 1. And if you're on that overlap line, then pick which one you want to do. And once you figured out what y value corresponds, tell me 2 things. What that y value is and what point must be on the graph. Gesundheit. Oh, and I guess it's reasonable for me to also say if, like, this is affecting my enunciation at all, just tell me, and I'll try to enunciate that off. The reason I'm going for it today is during the past 24 hours, I think I've gotten 3 emails from students saying that they're out sick. And it's all like stomach bug stuff, so this won't help anyway. All right, let's hear it. X equals 2. What do you get for y? Yeah. Negative 4. Do I hear a second for negative 4? Do I hear a different value? What you get? So what's another value people are saying? I also hear a negative 2. So, hearing multiple answers, let's go through the walk and see if we can pin something down. Unless you look like you're suddenly erasing.
Yeah, I did it in my head, so that's why.
Ah, okay. You see the error even. Okay. So, are we happy at 2, negative 2? Is that the universal agreed? And we can go through any one of these if people want. Let's plot that. 2, comma, negative 2. 2 by negative 2. When x equals 4, what do you get? Yeah. Is that universally agreed by the people who did that one? Excellent. So that means 4, comma, 2 apparently should be on the graph. 1, 2, 3, 4, 1, 2. And finally, x equals negative 1. What do you get when x equals negative 1? I go an 8?
Negative.
Negative 8. Cool. So, negative 1 by negative 8. And if you want to get an idea, maybe just try to interpolate between these in as straight a line manner as possible. So what does the graph of this equation look like it's becoming? Straight line-ish? So there are a few buzzwords. So the graph chart looks like a line. This is an example of something called a linear equation. which are a particular class of equations, and they're those equations whose graphs are lines. Feel pretty good? Nice. So, there's another flavor of equation, which is often important. These are things that are called graphs of functions. So if you happen to have a y value that is completely determined whenever you know the x value, something of the form y equals f of x for some function f, that's the graph of a function. These are important classes of objects, which we'll study an awful lot in this class. And let's just see an example. So let's try to sketch the graph of y equals x squared over 2. And there's an awkward page break here. Happily, the next page has the relevant information. So let's try to sketch the graph of y equals x squared over 2, and let's do it by doing the same sort of thing. Plug in some x values, see what y values result from those x values. Happily, in this case, there's no, solving to do. It's already solved, so it looks like y equals something that depends on x. So if you want to know what y is when x equals negative 3, just plug in x equals negative 3 to get y equals negative 3 squared over 2, and then just evaluate. Negative 3 squared is 9. 9 divided by 2 is 4.5. So when x is equal to negative 3, y is 1, 2, 3, 4.5. That idea seems pretty okay. So I think what I'll do is I'll plug in 1, and then I'll break you all up to do the remainder. Or maybe I'll let everyone do everything because I have to have some time to take attendance. So let's plug in x equals 1 and see what we get. So this will give me y equals x is 1. That's the same color again. Squared over 2. What's 1 squared? 1. So it's just 1/2, also known as 0.5. So it looks like when x equals 1, y is 0.5. That seems pretty okay. So, while I take rule, I would like you all to fill in the remaining couple of blanks, plot those points, and then try to interpolate between and get an idea for what the resulting shape will be. Well, you see, the issue is that I hit pause so I can take attendance because attendance probably doesn't belong on the recorded video. But I do have to hit record again. I'm sure that's not the only time that I'll do that. Groovy. All right. So, some particular things that are of interest when thinking about graphs of equations or graphs of anything are what are the intercepts. Whenever you have a graph, the x-intercepts of the graph are exactly what they sound like they should be. It's where the graph intercepts the x-axis. The x-intercepts of the graph are all points where that graph intersects spelling is very hard. I want the word intersect. Means it touches or crosses the x-axis. So, just by looking at the picture that we generated, where's the x-intercept of this graph? Yeah.
Origin.
The origin. Which origin is easy to say, but it's fewer letters to write 0, 0. The y-intercept, and I have this next line empty for a reason, is all points on where? Use the same voltage. Where the graph intersects the y-axis. So, same question. This thing that we just graphed, where is its y-intercept? Yeah. Still the origin. The x-intercept and y-intercept can be the same. If they're, then it's the origin, because that's the only place where the x-axis and y-axis cross. So there's how to read off the intercept geometrically. If you see a picture of the graph, you can just read them. If you want to do it algebraically, you can, if you have an equation. If you want the place where it crosses the x-axis, you want to see when y is equal to 0, because that's what the x-axis means. So to find the x-intercepts, you want to find all points on the graph with y equals 0. If you want to find the x-intercept, plug in y equals 0. If you want to find the y-intercepts, you want to find all points on the graph with x equals 0. That seemed pretty okay? And as was revealed in the previous section, there is an error here in that that is not the graph of that equation. This is an error that's entirely due to me. Here's the graph of, actually, you know what? I will use Desmos. Here's the graph of the equation 2x squared plus 3y squared minus 4x plus y equals 5. Let's make it big. Yeah, that's big enough. There we go. By looking at that graph, what's the approximate point about where are its x-intercepts? Yeah.
About like -1.5-ish, and 0, 1.5, and -1.5, 0, and 1.5, 0.
Yeah. So I'm going to cross this off. There's a QR code at the bottom, which, if I've done correctly, will link to exactly that graph. It works? Oh, good. It sure looks like the x-intercept. Oh, well, gosh, this is going to be confusing for me. I need both things up. And then I'll ask you to repeat that exactly. Where about are the x-intercepts? The x-intercepts are about -1.5, and you said comma 0, which is the more correct thing to say, and about 1.50. Cool. What about the y-intercepts? Yeah.
1.3, -1.3.
And I'm going to be a bit of a pedant. Just saying the number plus or minus 1.3 is technically not quite correct. That's the y value of the y-intercept. The y-intercept itself is the point. And during some moments, I might be pedantic enough to say that, like, that actually makes me upset. Never by much, though. So you can graphically read off the intercepts. That's what they are. Let's think about it algebraically also. Let's try to get these on the nose. I guess Desmos is also perfectly happy to give us its approximations. And you can do better, in fact, purely graphically by zooming in closer. But let's not do that right now. Let's do some algebra. Let's find the x and y intercepts by doing the algebra. So, algebraically, let's try to find the x-intercepts of, why did I cross this off? That was the wrong thing to cross off there. Let's try to find the x-intercepts of the graph of this equation by doing the walk. So if you want to find the x-intercepts, that means you're interested in when is y equals 0. So let's plug in y equals 0 and see what we get. The equation will become 2x squared plus 3 times 0 squared minus 4 times x times 0 equals 5. And that's an equation that I'd like to solve. Do all of those zeros, like, help me out a lot now? I think they do, right? 0 times anything is 0, and adding and subtracting 0 doesn't do anything. So I can drop those columns and just get 2x squared equals 5. There's an equation I'd like to solve. What would you do if you wanted to solve this equation? Well, possibly just one of the solutions. Steps on the answer. Yeah.
First off, I'd square root to get rid of the square on the left side, and then
So let's think about what happens when you just take the square root. So you have to take the square root of everything on that side. So this would become, and this isn't wrong, but this will result in a potential error. Take the square root of both sides. So you see how there's like that 2 under the square root? It's not a disaster because square root does behave nicely under multiplication. But you do have that square root 2. And what's special about the square root of x squared? Just x, well, kind of, not quite. It's absolute value of x. Right, if you take a negative and square it, you forget that it's negative. So we'll see the square root of 2 times x equals root 5. Okay, so what next? Divide by root 2. All right, and if absolute value of x is that number, then what things could x be? Plus or minus that thing? Yeah. All right, so it looks like plus or minus root 5 over 2 comma 0 is the location, are the locations of the x-intercepts. So, this got slightly harder than it needed to be. I'm going to suggest a different forced move. So it was annoying that when you took the square root of both sides, the 2 was still under the square root. So let's get rid of the 2 forced. So I'm going to go back up here and reorder steps a little bit forced. So how would you get rid of that multiplication by 2? Cool. So I'm going to suggest that as the forced move. Let's divide both sides by 2. And then how do you get rid of that square? Square root both sides. And whenever you get rid of the x by square rooting, as we saw right here, you get this plus or minus showing up. So we get the same answer. Cool. People feel pretty all right about this? And there's more than one way to solve an equation. So in the time that I was rambling on that, how many people just already found the y-intercepts? You don't. So let's start with this. What are the y-intercepts? Well, there are 2 of you that did it.
plus or minus square root of 5/3.
I hear a y equals plus or minus square root 5 over 3. Well, I guess you'd write that as 0, comma, plus or minus root 5 over 3, if you want to specify the point. That agree with what you got? Cool. So I'll pause for a second and see what people would like. I can wait for people to repeat the process. I can talk to it. Is there demand for me to go through the algebra? Cool. I see enough people doing it that I'll wait until a critical mass of people either agree with that as the y-intercept or disagree with it. I see some heads nodding. I like that. Cool. And maybe, while that's happening, I'll do the laziest thing I could. I will just have a machine check whether those are reasonable. So let's see, that's what I see for the square root of 5 over 2. Does that approximately agree with where we visually saw the intercept should be? Excellent. And the other one was division by 3. I hit 3, I swear I did. I didn't hit numlock. Does that about agree? Gesundheit. Excellent. So I think I believe these now. After going through the algebra, does anyone want to see it done? Awesome. So let's flip to the next page. So I will include some QR codes. I think I've set them up so they should work correctly if you just scan them. I've also provided actual alls. You can't click it because it's a piece of paper. If you go to the online version of the notes, though, you can see it. You can click it. So, right just then, we mentioned the idea of a function. So what is a function? A function is anything which is totally determined in terms of another thing. And that's a super vague notion. Well, let's just think about an example. Suppose you go out with a ball, you throw it up, and then you record its height at various moments in time. At any given moment of time, is that bowling ball in exactly one location? Yeah, the bowling ball can't be in 2 places at once. And I guess eventually the bowling ball will stop existing, and it didn't exist forever, but as long as the bowling ball exists, you can talk about its location. So that means the height of the bowling ball is a function of time. According to physics and some results from calculus, it is approximately modeled by height equals negative 5 meters per second squared, negative 5 meters per second squared being acceleration due to gravity, times time squared plus a term coming from the initial velocity, 20 meters per second times time. How many people would rather have that 5 be like 9.8 divided by 2? All right, that would be closer to truth, but that would also just be an approximation, and that's pretty close to 5 anyway, right? So I'll use that as my approximation for the acceleration due to gravity close to the surface of the Earth. Let's try to use this model to make some predictions. So at time equals 0 seconds, and well, maybe if you want to drop units, you could write that as just negative 5t squared plus 20t, as long as you just remember that time has to be measured in seconds and height has to be measured in meters. At time equals 0 seconds, what is the height of the bowling ball? Yeah. 0 meters. And that agrees, I hope, with the intuition. Before you throw the ball, it should still be on the ground. Well, I guess it's at whatever height you're throwing it from, but that's not accounted for in this model. At time equals 0, you get a height of 0. At time equals 1 second, what do you get? Yeah. 15 meters. Does that agree with other people? And maybe I'll include my units for now. Second for 15 meters? Or a different answer? Cool. People get 15 meters. All right. At time equals 2 seconds, what do you get? Sure.
20 meters.
I hear 20 meters. Do I hear a second for 20 meters? Great. Yeah, I think that agrees. I mean, I saw this roughly an hour ago because I teach this class twice, and I think I remember it being 20 meters. I also wrote the problems, but I can't remember them, after they're done. I'm going to do one more just because it'll be relevant in a second. What is the height at time equals 4 seconds? I'll pause for a second, see if someone else has got it. Yeah. 0. I hear a 0? All right. Oh, neat. So you can interpret something out of this. So this says that the height at time equals 4 seconds is 0 meters. What's like a plain English way of saying what that means? It's back on the ground. The ball has just landed. And now I'll ask kind of a generic question.
So you just plugged in a bunch of values for t and told me what the height is. Using these instructions for any value of t, any value of time, can you determine the height of the ball? Yeah. That's exactly what a function is. A function is anything that you can determine from another thing. A function from a set A, usually a set of numbers, to another set B, usually a set of numbers in this class, is any rule which takes a thing in A, usually a number, and gives a thing in B, again, usually a number. Said another way, a function is a thing which can be determined if you know what this other thing x is. That definition seems sensible? All right, so let's add some new words. The domain of a function is all of the valid inputs of this function. Let's think about the function that we just graphed. So this function should have domain given by all of the inputs for which it actually models the behavior of the ball, which will be after you throw it and before it lands. In order to see why you should restrict the domain, I'm going to jump to the next line below. Tell me, what happens when at t equals 10 seconds? Oh, yeah. The height at 10 seconds is negative. Did anyone actually figure out exactly how negative it is? I guess it doesn't really matter. I think it's around negative 300. I think it's exactly negative 300 meters. You disagree?
No, it's just a dumb height for a bowling ball to be at.
It is a dumb height for a bowling ball to be at. So what this model is predicting is if you throw the ball and you wait 10 seconds, then the bowling ball will have fallen 300 meters into the surface of the earth. Is that reasonable behavior for this to happen? So this behavior is definitely not in line with what physically should happen. The model does not give correct behavior. So you should think of t equals 10 as not being in the domain. In fact, the only times it should be in the domain are times starting when you throw it and ending when it lands. At what time did you throw the ball? T equals 0. That's how we assigned a time to be 0. At what time did we see that the ball lands? 4. So what does it look like the domain of this function is? Yeah. All values between 0 and 4. So I'll write that out exactly.
Would it include 0 and 4?
Ooh, let's discuss. So, at time equals 0, the height is at 0. Is the height being 0 a reasonable behavior for the height of the bowling ball to have? So should 0 be included? At time equals 4, the bowling ball has landed. Is height being 0 reasonable for the height of the bowling ball at the moment it lands? So I think that can be included. So it looks like it should be all values between 0 and 4 inclusive. What's like the interval way to write that? So the domain of this is all numbers between 0 and 4 inclusive. People feel okay? So whenever you have a model, the domain is all things that give reasonable behavior. The range of a function is all realized outputs. It's all numbers that actually occur as outputs of the function. So in the case of this height function, it will be all heights that actually get achieved. So let's start with this question. Is the height of this bowling ball ever allowed to be negative? We specifically restricted the domain to do that. Is the height of the bowling ball ever exactly 0? Yeah. So the minimum height this bowling ball achieves is 0.
I'm not going to justify the following fact right now. We will in a few days.
This bowling ball achieves its maximum height at time equals 2 seconds. As a consequence, what is the maximum height this bowling ball achieves? Say that R. I caught something that I think was good, but it was quite. 20 meters? 20 meters. Because that's the height at time equals 2.
If you know the time when the maximum height is accomplished, then just plug it in to find the maximum height. So the max height, since you already know the max of cars at t equals 2, is h of 2, which we've already computed to be 20 meters. All right. So let's now answer this question. What is the range?
So you know the ball achieves a height of 0 meters. It achieves a height of 20 meters. It doesn't achieve anything beyond that because that's the minimum and maximum. Does the ball achieve every height between 0 and 20 meters? Yeah, right. Like if you want to erect a wall at height 5 meters and threw the bowling ball up, it would have to crash through that wall to get up to 20 meters. And no matter where you put that wall, that would have to happen.
I guess it's a ceiling if it's horizontal. So it sure looks like the range is all of the heights between 0 meters and 20 meters, including or excluding endpoints. Including, right? Because 0 is an actual output, so is 20. Zero meters to 20 meters, and I'll include the units here because it's a physics level. The units probably matter. Nice. So, when you're thinking about functions in terms of something applied, they model something, you should care about what they model. But a lot of the functions that we'll study in this class will be fairly abstract as functions, in which case you can still do everything. You just don't have to worry about whether the behavior is reasonable.
So here's one such function. For any number x, let f of x be the distance from 0, 0 to x comma 1. And let's just ask ourselves, if this is a function. If you knew what the value of x was, could you definitely compute that distance? Yeah, I think so. And let's see that in practice. Plug in x equals 2. Tell me, what is f of 2?
So I guess I'll write it down in words. This is a verbal description function. So f of 2 is the distance from 0, 0 to, I'd like to plug in this value for x, 2, comma 1.
Does that look like something we know how to compute? Yeah, in fact, current people just have already computed in the time that I've spaced back and forth. Let's use the distance formula and make this computation.
It's not stolen. Right, so the distance formula is given by the square root of the difference between the x's squared plus the difference between the y's squared. So doing that, this will be the square root of difference between the x's. 2 minus 0 is 2, squared is 4, plus 1 minus 0 is 1, squared is 1. So it looks like this distance is exactly the square root of 5. Does that agree with other people? Nice. Do you think we could do exactly this for absolutely any x value? If we do that, we can get a formula for the function. Something that conceivably we could do something like graph if we wanted to. So let's find a formula for f of x. So this general thing, f of x, it is the distance, which we called d in the past, from 0, 0 to x comma 1. And let's see what this is. So this is the square root of the difference between the x coordinates plus the difference between the y's, and then that square rooted. Pretty okay? Is there some obvious simplification that we should do? Does minus 0 matter? So we can erase the minus zeros, and what's 1 squared? 1. So it sure looks like there we have a formula for this function. X squared f of x is x, the square root of x squared plus 1. So once we have a formula, we can start doing things with that formula. You can plug a formula into a formula. If you want to evaluate f of x squared minus 2, well, that means I want to take that formula, x minus 2, and plug it in for that x. Let's see what we get when we do that. This will be the square root of x minus 2 squared plus 1. Should we do anything to simplify that? And this is like a legitimate question. Do people want to see some simplification done? Cool. Well, let's do it. So I guess we should start by like FOILing. And I see x minus 2 squared. And just in order to like see that happen now very explicitly, I'll do that off to the side explicitly. When you square x minus 2, what does squaring mean? It means you multiply it by itself. I now see like a binomial times a binomial. The way you expand that out is with the acronym called FOIL. So let's FOIL that out. This will be false terms multiplied together. Outside, negative 2x is minus 2x. Inside, minus 2x. Negative 2 times negative 2 is 4. So this will be the square root of x squared minus 2x is minus 4x plus 4 plus 1. That feel pretty okay? And like we can't get rid of the square root. There's no hope of that. And arguably what we just got isn't that much simpler looking. But sometimes it's useful to do that. If we take g of x to be the square root of x, then we can evaluate the composition function, f of g of x, by plugging in a square root of x where we see that x. So this will be f of root x. And let's do that. Let's take this formula and replace the x with the square root of x. So this will be big square root thing squared plus 1. And the thing that goes in those parentheses is square root x. How do people feel? Nice. Any simplification that we should do? Yeah. If you take a number and take its square root, that number is the number which when you square it, you get x out. Right? That's the definition of square root. So, this is just x. This is the square root of x plus 1. And the next thing I want to do is somewhat subtle. Let's talk about domain. So whenever you have a function and you're asked what the domain is, you want like all valid inputs. So let's try to compute the domain of this function. And the answer that we get the first time will be somewhat wrong. So let's try to compute the domain of this. And I'm going to do something slightly wrong. I'll use this formula to compute the domain. So let's try to compute the domain. That's all valid inputs.
So how do you compute the domain? Well, let's just think about what this x is. Let's ignore the square root part. Is there any number you can't add 1 to? So there are no issues yet. Are there any numbers you're not allowed to see inside of the square root? Negatives would be bad. So the thing under the square root has to be non-negative. So figure that out equal to 0.
I'm going to, the first thing that I'm going to do is going to be slightly wrong. So it looks like the thing under the square root has to be bigger than or equal to 0.
Okay, cool. Does that look like an inequality that's easy to solve for x? Yeah. What is that, the solution to that inequality?
X is greater than or equal to -1. And let's put that in interval notation. What is that as an interval? That's correct. I just want to write it another way. Yeah.
Bracket -1, comma, infinity.
Nice. And what declaration should go by the infinity? Parentheses. Always a parentheses by infinity. You never include infinity. Cool. Does that look like, does anyone at a glance see what is wrong right now with that as the answer? Yeah.
Can't have -1 included. Why not? No, you are right. For a different reason than that.
Let's think about what the original instructions were. The original instructions were take the square root, then feed that to add. So let's plug in x equals -1 and see what happens. There's the thing that we need to compute. Is there anything wrong with that?
You can get the square root of negative.
That's bad. So this domain is incorrect.
So the payoff is the item just below this statement of trick question. You always figure out the domain before you simplify. Whenever you simplify, you might accidentally change the domain. And we'll do this explicitly next time because I see that I am maybe 40 seconds over time. So I'll stop here.
And what I think I would like you to do between now and tomorrow is think about this expression right here before any simplification happens. Tell me what the domain of this is.
Are your office hours still open today?
Yep.
It's just in your office?
Yep. If you head up to the 5th floor, if you take the elevator and turn left, you'll see me.
I will be there. Thank you.
Yeah, I will see you there.
Yelling or shouting or.